Your async Rust code might look perfect, but one slow API call can silently freeze your entire system. No crash, no error, just stuck. And most developers don't even realize it's happening. In async Rust, features don't fail just because they take too long. If a task never completes, your system just keeps waiting. This is especially dangerous in real-world systems like APIs, database, and microservice. So let's look at this example where we have a fetch data function which fetch for around 10 seconds, and we are awaiting that function in our main.rs. This looks fine, but imagine this is a network request. What if it never responds? Now imagine hundreds of these requests. Threads are being occupied, requests pile up, latency explodes. Eventually, your service becomes unresponsive. This is how systems fail, and not with crashes, but with silence. To fix this, we use timeouts. So let's implement Tokio timeout in our code. So let's create a variable first, and we are going to wrap this inside timeout of Tokio timeout, and which takes two arguments. First is duration, and our future, which is fetch data. So let's call fetch data here. We remove await from here, and for duration, we'll pass 3 seconds. So what it means is, uh, if a future takes too long, so it will wait for around 3 seconds, and if it does not return the our result, it will return the error. Otherwise, our result. So actually, it is returning a result and elapsed error. So now we're going to use mesh statement for that and print our result or time of failure. So now let's run our program, and it will only wait for 3 seconds. After that, if it does not return under 3 seconds, it will return timeout error. So as we can see, our timeout error is printed in our terminal. Timeout wraps your async task. If it does not finish within given duration, it cancels it. Now, instead of waiting forever, you regain control. Under the hood, the runtime like Tokyo is polling your future. When the timeout expires, it stops waiting and returns an error. The future gets dropped, effectively cancelling the task. In real systems, timeout alone is not enough. You combine it with retries like try, timeout, retry, and then fallback. Every external dependency must have a deadline. No timeout is equal to infinite trust. And in distributed systems, that's a bug. So where do we need timeout? Like we can use timeout in API calls, database queries, payment gateways, third-party services. Anywhere you don't control the response time, you need a timeout. If your async Rust code does not use timeouts, it's not production ready. And the worst part is it might fail silently.